Hello! Dun sa previous lesson natin, inintroduce natin yung concept ng continuity ng isang function at a single point. So now, we will take a look at the continuity of a function at a single point if we have two continuous functions, let's say f and g. Yung sum ba ng dalawang continuous functions sa isang point na a, continuous pa din sa a. And will that be the same dun sa difference, product, at sa quotient nung dalawang continuous functions, f and g. Remember, continuous sila at a point A. We're not saying that the entire function is continuous. Only dun sa point na A. Let's consider first yung sum ng dalawang continuous functions. So, anong ibig sabihin ulit pag continuous si f at si g? Ibig sabihin, pag in-evaluate natin yung function sa A, equal siya dun sa limit ng function when x approaches a. So, the limit as x approaches a of f of x is equal to f of a, and the limit as x approaches a of g of x is equal to g of a. Ang gusto nating makita, based sa definition natin ng continuity, ay yung limit as x approaches a ni f plus g ay equal sa f plus g evaluated at a. Now, if we go back to our limit theorems, ang limit as x approaches a ni f plus g of x ay equal sa sum ng limits as x approaches a ng f at nung limit as x approaches a ng g. Pero based dun sa nakita natin earlier, yung limit ng f of x as x approaches a at yung limit ng g of x as x approaches a, since they're both continuous at a, ay f of a at g of a respectively. At si f of a plus g of a, pwede natin siyang isulat na f plus g of a. And so we have shown that the limit of f plus g of x whenever f and g are continuous at a as x approaches a is equal to pag in-evaluate natin yung f plus g sa x equals a. So, nakuha natin yung result na gusto nating makuha. Now, based on sa results natin, we could say that if f and g are both continuous at a, then f plus g is also continuous at x equals a. Now, pwede nyo gawin yung similar na proof, similar na argument to show that the difference of f and g is also continuous at x equals a, the product is continuous at x equals a, and the quotient is continuous at x equals a. As long as, syempre, the denominator is not 0 whenever x is equal to a. So, g of a is not equal to 0. Now, let us consider polynomials. So, f of x is equal to this general polynomial expression. So, meron tayong constants b sub 0 hanggang b sub n, and we have x terms na may exponents from 0. So x to the 0 is just equal to 1. X to the first power to the second power all the way to the nth power. And since we know that x raised to n where n is a natural number, kasama na rin yung 0, ay continuous for all real number values of x, then this means that all polynomials are continuous everywhere. Again, for any value of x in the set of real numbers, a polynomial function is continuous. Now, let's consider our rational function na dinedefine natin as a polynomial over a polynomial. So, g over h, g and h are both polynomials. So, this would be the situation, similar dito, na we are looking at the quotient of f and g, where f and g are both continuous. Kasi nga, polynomials yung f and g in a rational function. Except this time, ang tinitignan natin ay g at h. So this implies that rational functions are continuous throughout their domain. Well, akala ko ba hindi siya continuous at, kunyari, x equals a if h of a is equal to 0? Totoo naman yun. But remember, kung isi-0 ni a ang denominator, edi wala siya sa domain nung rational function natin. So, meron pa rin tayong discontinuity sa a if the denominator will be 0 at a. But again, wala na siya sa domain ng function. So, whenever nandun tayo sa domain ng ating rational function, continuous yung ating function. So, for an example, we want to determine where f of x equals x cubed plus 2 all over x squared minus 9 is continuous. We take note that the numerator, x cubed plus 2, is a polynomial. So, this is continuous everywhere. And the denominator is also a polynomial. So, it's also continuous everywhere. Ang titignan na lang natin ay kailan ba magiging undefined yung rational function natin. So this will be undefined when the denominator is equal to 0 and the denominator will be equal to 0 whenever x is equal to 3 or x is equal to negative 3. Therefore, our function is continuous everywhere except at 3 and negative 3. So we'll use the set of real numbers except the elements negative 3 and 3. Using the interval notation, our function will be continuous from negative infinity to negative 3. Then syempre sa negative 3, discontinuous siya. Then again, from negative 3 to 3. Then pagdating ng 3, may discontinuity ulit. And then again, from 3 all the way to positive infinity. Open intervals lahat. Ang titignan naman natin ngayon ay radical functions where f of x is equal to the nth root of x, where n is greater than 0, and is of course a natural number. So first case, n is odd. Pag n is odd, pwedeng negative yung values ng x sa loob. And in that case, our nth root of x is continuous everywhere, which means for all real values of x. But if our n is even, yung index natin is even, we know na hindi pwedeng maging negative yung radicand. Kasi magkakaroon tayo ng imaginary na result. But as long as positive yung value ng x, meron tayong mahahanap na nth root. So if n is even, then our function nth root of x, again even yung n, is continuous for all values of x that are greater than or equal to 0. Now let's go back to the first slide of our continuity lesson and let's take a look at the third definition. Notice na gumagamit siya ng epsilon and delta, which ginamit natin nung una to formally define what a limit is. Na for any or every epsilon na pwede mong ibigay that is greater than 0, makakahanap ako ng delta, which is also positive, such that for all x na x minus c is less than delta, in our case, a yung gagamitin natin, then f of x minus f of a will be less than epsilon. So, ibig sabihin, pag gumamit ako ng x na mas malaki or mas maliit kay a by a small amount na delta lang, yung difference ni f of x at ni f of a ay mas maliit dun sa, yung absolute value nun, kasi pwedeng negative, ay mas maliit dun sa epsilon na binigay mo. So, yung definition ng limit, the limit of f of x as x approaches a is equal to L kung for any epsilon greater than 0, may nag-exist tayong delta na positive din such that if the difference between x and a, absolute value kasi either side of a yung i-consider natin, is less than delta, then yung difference nung function, pag in-evaluate natin dun sa x na yun, no, na hindi lalayo ng delta, minus yung actual limit, ay hindi naman lalampas ng distance na epsilon from the limit. Pero ano nga ba yung definition natin ng continuity? Continuous yung function natin at x equals a pag yung limit of the function as x approaches a is equal to f of a mismo pag in-evaluate natin siya. So, ano yung naiba niya sa definition ng limit? No? Yung L na limit, mapapalitan siya or magiging mas specific siya na it's actually f of a. So, we could just take this whole definition of the limit and modify it a bit. So, I'll take it. And taking the fact na alam natin na yung limit na L, to, ay f of a. If we are talking about continuity, then we can use an epsilon delta definition for continuity. And it goes like this, no? Na for any epsilon greater than 0, there would exist a delta greater than 0 such that if the distance, no, of any x na gagamitin mo from a, kung saan natin evaluate yung limit, ay less than delta, kung malapit dun sa a yung x value, na yung lapit ay hindi lalampas ng delta, then yung difference nung resulting value ng function dun sa x na ginamit mo from f of a ay hindi lalampas ng epsilon. And if that is true, then our function is continuous at a. And so we have actually reached the third level of the definition of continuity. All the way to university, as long as hindi kayo magte-take ng math na major, hanggang dyan na yung continuity definition na magagamit nyo, na makikita nyo. So, wag nyo kakalimutan kasi lalabas yan sa lahat ng calculus courses nyo na college. Regardless kung mag-bio kayo, chem, physics, engineering. Makikita nyo yan. So let's end here for now and we'll look at some examples sa next lesson natin.